We are often told that you should eat rich food in moderation. But if you were the freshwater snails I study, your strategy instead would be to eat as much rich food as possible. Snails use the energy from this food to grow, reproduce, move, and do one other important thing: release parasites into the water. These parasites can also cause human infections, such as the devastating neglected tropical disease schistosomiasis, which is what I study. Humans become infected with schistosomiasis when they encounter these free-living parasites in the water that are released by snails. And the more parasites that are in the water, the higher the infection risk to humans. And the most important thing for you to understand about this system is that snails produce more parasites when they have access to rich, abundant food. The problem for the snails is that they don't actually have access to high quality food constantly in their environment. As you can see, usually food that's rich comes in pulses caused by events like heavy rain bringing in fertilizer runoff or sewage overflow into these water bodies. And this nutrient pollution that causes food pulses um, can make it so that, um, hmm, that's why we have the timer. The nutrient pollution that comes in there also causes these unexpected consequences. So what I mean by unexpected consequences is if I give an individual snail food that's really rich, it's going to be obvious what happens to it. It's going to get bigger, it's going to reproduce, and it's going to make a lot of parasites. But at the ecological community level, we don't have just individuals. We have individuals of different traits. They're not identical. So they may be a different size. They may be differently reproductively mature. Some may be infected, some may not be. And it's the mix of these traits together that determines how intensely they compete with each other for food. And that's important to study, even though it's hard, because how much food they have tells us how many parasites they can make because of how much energy is available for them. So even though it's hard and it's still important to do, how are we going to do this? How are we going to predict what happens at the community level? My dissertation uses disease ecology to do just that. And in general, my dissertation studies how mixes of snail traits and also things like their environment or their food quality impact how many parasites they make. I did a simulation study where I had snails in this huge population and their parasites, and I did it over a transmission season. So what I found is that you have a food pulse in the middle of the transmission season. That's going to cause the most parasites to happen as opposed to any other pulse in the season. The reason why this period of time is so critical is because snails have been around long enough to mature, to become heavily infected, and they're about to starve to death because they're competing with each other. This food pulse comes in, rescues them from starvation, and makes it so they have plenty of parasites to eat. I've tested this in my little fake ponds, and I found the same thing too. So in conclusion, I guess what I'm telling you is that timing is everything, especially for food.